Slide 1 serves as the title cover for the Technology in Education course, DD 4123, introducing the research topic, Empowering Practical Pedagogy, a blended learning design model via the Chaoxing Fanya all-in-one platform. Set against a futuristic blue backdrop featuring a robotic hand interacting with a glowing digital interface, the slide prominently establishes the presentation's focus on educational technology while displaying key academic metadata, including the presenter, Lu Yang, institution, Nila University, MED, and lecturer, Dr. Going Soon. Slide 2 transitions into the presenter's personal introduction with a title, Professional Profile. Featuring a clean, dark blue background, this section covers the presenter's background, career goals, and educational philosophy within the context of vocational training. Here is a single paragraph explaining the slide. This slide highlights the presenter's career background and goals, illustrating a journey anchored in strong leadership experience and a clear vision for the future. On the left, Administrative Foundation emphasizes 8 years of administrative leadership experience focused on daily operational management, institutional coordination, and interpersonal communication, skills that ensure precise class organization and robust student support. On the right, Vocational Education Aspiration outlines a long-term dedication to transitioning into vocational training and student cultivation, aiming to blend administrative efficiency with modern instructional design to equip graduates for success in the industry. Slide 4 highlights the presenter's key professional strengths, emphasizing over 8 years of administrative expertise in an educational setting. It outlines 3 main competencies: organizational coordination to structure schedules and workflows, student-centric communication to build supportive mentor-student relationships, and practical resource management to align facility assets with course objectives, all complemented by a graphic celebrating Education Technology Day. Slide 5 outlines the presenter's educator role and philosophy, focusing on 3 core pillars that shape their approach to teaching. It defines the teacher as a learning guide who builds step-by-step pathways for autonomous knowledge building, an in-class promoter who energizes classroom dynamics through interactive training, and an enthusiasm stimulator who boosts student confidence by setting achievable practical goals, all accompanied by an image depicting a technology-enhanced learning environment. Slide 6 acts as a section divider introducing pedagogical integration, maintaining the presentation's sleek dark blue aesthetic. It focuses on bridging the gap between theory and practice by linking technical expertise directly with real-world instructional methods. Slide 7 details technical skill application, breaking down how theoretical concepts translate into hands-on learning through 2 key strategies. First, practical task alignment directly connects specialized technical capabilities to classroom assignments so students solve authentic operational challenges instead of abstract exercises. Second, industry real-case carriers adopts genuine industry workflows and market data models to provide students with first-hand exposure to modern vocational standards and expectations. Slide 8 outlines the presenter's core teaching strategies through 3 distinct approaches designed to drive active learning. Scenario simulation constructs realistic professional environments where students execute practical tasks under simulated real-world constraints and metrics. Interactive methods utilizes group collaboration, peer review, and active role-playing to transform passive receivers into dynamic skill executors. Finally, seamless integration synthesizes professional strengths with instructional design to facilitate natural, high-efficiency mastery of technical competencies. Slide 9 introduces a new major section centered on the TAC framework, maintaining the presentation's dark, modern aesthetic. The subtitle clarifies the core topic, Technological Pedagogical Content Knowledge in Vocational Contexts, signaling a shift toward exploring how technology, pedagogy, and subject matter expertise intersect within vocational education. Slide 10 details the core TAC components, breaking down the fundamental elements of the framework into 3 key pillars: content knowledge, CK, pedagogical knowledge, PK, and technological knowledge, TK. Content knowledge encompasses domain-specific subject matter expertise, underlying operational logic, accounting rules, and compliance standards. Pedagogical knowledge focuses on universal teaching strategies, tiered task design, scenario simulation, and formative peer assessment methods. Lastly, technological knowledge covers general digital platforms, such as Chaoxing Fanya and Tencent Meeting, alongside specialized training tools like OBS and Figwa Data. Slide 11 delves into content knowledge (CK) within the context of live e-commerce, outlining 4 core operational areas essential for domain mastery. It covers traffic distribution logic, which focuses on underlying algorithm mechanics and gross merchandise value (GMV), accounting formulas, traffic differentiation, which distinguishes the operational principles of organic user acquisition versus paid promotion, script and compliance structure, which details sales script construction and regulatory guidelines for live streaming, and product and retention strategy, which focuses on product selection, user retention funnels, and order conversion techniques. Slide 12 focuses on pedagogy and technology, contrasting the practical applications of pedagogical knowledge (PK) and technological knowledge (TK). Side by side. On the pedagogical side, it emphasizes instructional methods such as group project training, scenario simulations, tiered tasks tailored with simplified requirements for beginners, and formative assessment conducted through peer review and presentations. On the technological side, it categorizes tools into general platforms, Chaoxing Fanya, Tencent Meeting, Mind Maps, specialized tools, OBS Studio, e-commerce simulation backend, Figwa data, and core digital operations like screen projection, video recording, and cloud document sharing. Slide 13 details a PCK implementation case, focusing on a hierarchical traffic push simulation, no digital tools, which explores how core subject knowledge can be taught through non-digital pedagogy. Centered on understanding live platform traffic allocation algorithms and audience retention thresholds, the activity divides students into roles as platform auditors and new live streamers. Through interactive role-playing, students simulate user dwell times and engagement metrics to demonstrate traffic push tier jumps, highlighting the pedagogical value of deconstructing complex algorithmic concepts without reliance on digital technology. Slide 14 explains TCK and TPK integration, illustrating how technology merges with both course content and pedagogical strategy within the TPAC framework. On the left, TCK, technological content knowledge, highlights the use of e-commerce data dashboards, such as Figwa data, to present real-time traffic curves, transaction volumes, and conversion reports rather than relying on static spreadsheets. On the right, TPK, technological pedagogical knowledge, emphasizes flipped classroom and collaborative dynamics, where instructors upload preview microlessons on Chaoxing Fanya prior to class, gather immediate feedback via online polls, and have students write team project reports synchronously using cloud documents. Slide 15 introduces a comprehensive TPAC case focused on vocational live streaming training, setting the practical background for applying the theoretical framework. It defines the teaching context as working with beginner students who have direct access to live streaming computer facilities, emphasizing an instructional model built around hands-on, practical simulation to bridge technology, content, and pedagogy effectively. Slide 16 breaks down the core components of the TPAC model within the context of the live streaming training case. Content knowledge, CK, covers fundamental e-commerce subjects, including product listing, coupon configuration, and conversion optimization strategies. Pedagogical knowledge, PK, details the instructional approach, utilizing a 3-stage task-driven learning model featuring tiered assignments and structured peer output reviews. Finally, technological knowledge, TK, identifies the practical digital tools integrated into the lesson, specifically OBS Studio, the CapCut video editor, and the Chaoxing platform backend. Slide 17 outlines the TPAC instructional process, highlighting the first 2 sequential phases of the learning workflow. Phase 1, pre-class, focuses on self-paced preparation where students watch designated microlessons on Chaoxing and attempt foundational knowledge quizzes to build core understanding. Phase 2, in-class data, transitions into real-time application as students analyze live data dashboards within backend systems to evaluate key traffic metrics and gain practical, data-driven insights. Slide 18 continues the TPAC instructional process, detailing the final 2 stages of the learning framework. Phase 3, practice, involves active execution where students perform group live streaming practice sessions that are recorded using OBS Studio software. Phase 4, post-class, completes the cycle by having students project their recorded footage for peer evaluation and group feedback, ultimately wrapping up the lesson with formative scoring. Slide 19 introduces a real-time classroom monitoring dashboard, highlighting a key component of the platform's analytical capabilities. Styled with green cursive text on a dark background, the slide acts as a focal point or title card for showcasing how instructors can track student participation, progress, and engagement live during active learning sessions. Slide 20 introduces check-in monitoring, continuing the showcase of the platform's real-time analytics features. Presented in the same green handwriting style font against a dark background, this slide serves as a transition or caption highlighting how the system tracks student attendance, promptness, and active presence at the start of or throughout a class session. Slide 21 acts as a section title slide introducing the Chaoxing Fanya guide, signaling a transition into the practical and technical side of the platform. Featuring the presentation's signature dark backdrop and clean green visual accents, the subtitle, Operational Walkthrough of the Integrated Online Workstation, highlights that the upcoming section will break down the platform's features, navigation, and core functionalities step by step. Slide 22 outlines the platform operations matrix, detailing a structured four-step workflow for navigating and using the online workstation. It begins with portal access, Step 1, for viewing user manuals and downloads, followed by workstation login, Step 2, to unlock course construction, bulk assignment grading, and anti-cheating controls. Users then navigate through the Navigation Hub, Step 3, to choose from 7 primary tabs tailored to specific teaching demands, before arriving at the course workspace, Step 4, where instructors manage courseware, assign homework, launch tests, and track comprehensive student learning records. Slide 23 focuses on the portal navigation modules, breaking down 3 core functional hubs available within the platform. The Campus Courses module allows users to filter school-built professional courses, search target titles, and directly enter their course workspace. The Big Data Center provides comprehensive analytical oversight by visualizing real-time student learning data, completion rates, and participation statistics. Finally, the Resource Library serves as a centralized content repository, granting access to extensive free ebooks, academic journals, MOOCs, and mobile library literature resources. Slide 24 details the course and assignment system, highlighting 4 key functional capabilities that streamline platform administration and instruction. It features bulk material management for batch uploading courseware slides, video microlessons, and syllabus guidelines, alongside streamlined assignment workflows that handle setting submission deadlines, batch grading student work, and exporting performance scores. To ensure assessment integrity, anti-cheating restrictions configure online examination time constraints, randomized question banks, and focus monitoring, while interactive forums support engagement by fostering student-faculty discussion threads and collaborative peer Q&A channels. Slide 25 outlines the Learning Analytics System, detailing 3 key features that enable data-driven monitoring and evaluation. It highlights real-time tracking for measuring video watch percentages, chapter quiz completion, and overall study duration, alongside student progress maps that leverage automated platform activity logs to identify struggling students early on. Additionally, the system provides data explorability, allowing instructors to generate comprehensive academic reports for institutional quality assurance and evaluation. Slide 26 serves as a section title slide introducing the blended learning closed loop, marking a shift toward the overall instructional structure and evaluation frameworks. Styled with the presentation's signature dark background and vibrant green accents, the subtitle Full Cycle Pedagogical System and Assessment Metrics indicates that the following slides will detail how pre-class, in-class, and post-class activities come together into a continuous, data-informed teaching cycle alongside key metrics for measuring student success. Slide 27 presents student learning outcomes using a clean horizontal bar chart that measures key performance indicators across the blended learning cycle. It demonstrates high levels of engagement and performance, highlighting a 92% pre-class completion rate, 88% practical mastery, 85% in-class interaction, and a standout 95% peer assessment rate. Together, these quantitative metrics demonstrate the effectiveness of the interactive, data-driven teaching model in driving student participation and skill acquisition. Slide 28 outlines the formative assessment model using a pie chart to show the proportional breakdown of continuous evaluation throughout the learning module. This breakdown illustrates how grading and feedback are balanced across pre-class preparation, active in-class participation, practical application, and peer feedback to foster continuous learning and holistic achievement. Slide 29 serves as the concluding summary and Q&A slide titled Beyond Limits, Empowering Educational Innovation Through Chaoxing Platform and Visual AI Tools. Featuring a graduation cap icon atop the dark backdrop, it synthesizes the core message of the presentation, integrating technological knowledge, TK, and AI visual tools into the TAC theoretical framework to build a stable, future-oriented learning ecosystem for vocational education. Finally, it wraps up the session by inviting questions and discussion, concluding the presentation under Nilay University. Slide 30 functions as an image sources reference slide, serving to credit external visual assets used throughout the presentation. Set against the signature dark backdrop, it features a prominent header in blue along with listed hyperlinked URLs and corresponding thumbnail previews, ensuring academic integrity, proper attribution, and transparency for all featured imagery.